So the next kind of matrix that I want to talk about is that are elementary row operation. The next matrix that I want to talk about that corresponds to an elementary row operation is the scaling or multiplication matrix. So essentially what we're looking to do is we're looking to multiply an entire row by a scalar. Oftentimes we're using this in order to create a leading one or a pivot. And so like say for example, I've got 2, 1, negative 1, 3, okay? And I want to multiply row 1 by 1/2 to give me 1, 1/2, negative 1, 3. Okay? The elementary matrix that I'm going to use will have a k in the row that corresponds to where I want to multiply the scalar, and everywhere else it will be the identity matrix. So in this case, what I want to do is I want to actually construct, I want that k to be 1/2, so I'm going to take 1/2, 0, 1, 0, 1. So the identity matrix with a 1/2 inside of the first row. Then I'll multiply that by my original matrix, 2, 1, negative 1, 3. And you'll see that that then gives me 1/2, 2, and then 1/2, and then the bottom one will remain unchanged. Bottom row ends up remaining unchanged. And there you go. So that's the idea. Okay. What we'll say is we will place the scalar k in the row that corresponds to the row we want to change. Okay. So like let's say for example, now we've got this matrix. 1, negative 3, 5, 2, 3, 2, negative 1, 0, 5, 2, negative 2, 1. Okay, and what I want to do now is I want to multiply the second row by 1/3 in order to get a leading one right here. Okay, so what I'll end up with is 1, negative 3, 5, 2, 1, 2/3, negative 1/3, 0, 5, 2, negative 2, 1. Now, because this is a 3 by 4 matrix, what I'm going to need is I'm going to need a 3 by 3 matrix to left multiply by. So what I'll do is I'll say, okay, that 3 by 3 matrix, now it's going to be the identity matrix, except it's going to have a 1/3 in the second row because that's actually the one that I want to change. I want to change the second row, so I'm going to place my scalar in the second row. And then I'll take it and multiply it by my original matrix. And after a little bit of work, kind of see the first row is not going to change at all. It's going to end up being 1, negative 3, 5, 2. And then second row, though, is going to be 0, 1, 0. 1/3 times 3 is going to be 1. 0. 2 times 1/3 is 2/3. And then 0. 0. 1, negative 1 times 1/3 is negative 1/3. And then 0 plus 0 plus 0, and that's 0. And then the last row, right, this one here, that's not going to end up changing the row at all, so that'll end up being 5, 2, negative 2, 1. All right? So, in order to develop an elementary row matrix that, in fact, scalar multiplies one of your rows, what you'll do is you'll construct the identity matrix that will allow you to left multiply. And then you will replace the kth row, the row that you want to change, the kth row with the scalar you're multiplying by. And that's it.